All right, welcome to your first lesson in circles. This is Unit 10, our very last unit, and I am excited to get started. So this page that you see right now that has these 9 vocab words on it, you may want to screenshot this, pause the video when I'm done drawing these, and draw them yourself. Keep them very close to you because this vocabulary is going to be very important to you as you go through this unit. So let's get started. All right, first of all, let's talk about what a radius is. A radius is a segment that goes from the center of the circle to a point on the circle. So this is the center, we'll call that A, and we'll call that B. So a radius goes from the center to a point on the circle, and all radii in a circle are the same. For example, if I draw another radius and I make this point C, then AB is equal to AC. So all radii are equal to each other in the same circle, and they start at the center of the circle. All right. A diameter is a segment that goes through the center of the circle. Again, let's talk about circle A. A diameter goes all the way through from one side of the circle to the other side of the circle, and it has to go through the center. So we'll call this B, and we'll call this C. All right, and a diameter is 2 times a radius. All right, and a radius is half a diameter. All right, that's an important relationship for you to know. Now let's talk about a chord. A chord is any segment that starts and stops on the circle. For example, this would be a chord, and here's the center of our circle, circle A. This would be a chord, we'll call this BC. This would be another chord, we'll call this DE. This would be another chord, we'll call it FG. Any line segment that starts and stops on the circle is a chord, and the diameter is a special type of chord. So a diameter is also a chord. A diameter is a chord that goes through the center. And a chord starts and stops on the circle. Okay, let's talk about a tangent. This is one of those words that you saw in your circle vocabulary activity. A tangent is a line that is outside the circle that touches the circle at one spot. For example, if this is a point right here, a tangent line touches that circle at exactly one spot. All right, so it does not go through the circle. It starts and stops outside the circle without going through the circle. That is a tangent. So it touches the circle at one spot. And that point where it touches the circle is called the point of tangency. And that's going to be important. All right, I'm going to come straight down from here and talk about a secant. So a tangent goes through the circle at one point. A secant is a line that goes through the circle at 2 points. So it looks kind of like a chord, except it keeps going. So the A, B. All right, and this goes through the circle at 2 points. This is a line. It's not a segment, it's a line. It stops, it never stops. It keeps going forever. So it goes through the circle at 2 points. All right, now let's go talk about central angles. No, orange. I say orange. Okay, a central angle is an angle at the center of the circle. So if this is the center, we're going to call it A. A central angle is an angle made with 2 radii. Those are really ugly radii. Oh, well, you get the idea. B, C, okay? A central angle, you see how this central angle right here, a central angle is made from 2 radii. Angle at the center made from 2 radii. And that's just plural for radius. English lesson for the day. Okay, now let's talk about an inscribed angle. An inscribed angle is an angle on the circle made from 2 chords. So what I mean by that is that's a chord, that's a chord, this is an inscribed angle. So we'll call this B, C, and D. So it's an angle on the circle created by two chords. All right, now let's talk about an arc. An arc is a piece of the circle. I want you to think about a pizza and think about the circumference of the pizza being a crust, and the arc would be one piece of crust. So like one piece of pizza, it's crust. An arc is just a piece of the circumference. So like this right here is an arc. Just from here to here. That is an arc, okay? It's a piece of the circle. Piece of the circumference. Now, there's two types of arcs. There's major arcs and there's minor arcs. A major arc is any piece of the circle that's bigger than half the circle. So it's greater than 180 degrees. So we know that a circle is 360 degrees. A major arc is any arc that's greater than 180 degrees. So on our circle, that would look like this. If this was our center, so this would be half the circle. So our major arc would start here and go all the way around, bigger than half the circle. That is a major arc, any arc that's greater than 180 degrees. And then we have what's called a minor arc. And a minor arc is less than 180 degrees. So less than half a circle. And you can see that that would be this little piece right here. That's our minor arc. So a major arc is greater than half the circle. A minor arc is less than half the circle. A semicircle is exactly half the circle. So if this was our center and this is a diameter, then this is a semicircle and it is exactly 180 degrees. It is an arc that is exactly 180 degrees. It's half a circle. All right, so that is your circle vocab. Now, again, if you want to screenshot this, if you want to pause the video and write all of this down, this vocab is going to be very, very important to you as you're going through this lesson. So now let's talk about some formulas. So we have area and circumference that we're going to talk about. These are the first two formulas for circles. And the area formula, you know, you've done these formulas before. The area formula is A equals pi r squared, where r is the radius. Where r is the radius, all right? And then your circumference, and remember the circumference is the length all the way around the circle, and that is C equals 2 pi r, or pi times d. Those are the exact same formula where r equals the radius and d would be the diameter. And it doesn't matter which one you use here. If you're given the diameter, then use the diameter formula. If you're given the radius, use the radius formula. All right, here we go. So we're going to find the area and the diameter for all four of these circles, area and diameter, area and circumference for all four of these circles. And since I know that you guys at home may not have a calculator that will do pi for you, we're just going to use 3.14 as pi, okay? So use 3.14 for pi, okay? All right, so number one, now let's first write down what we know about this circle. This circle gives us that 12 is our radius. It's that little half piece, so r equals 12. All right, so now let's find our area and our circumference. So our area is pi r squared, so we do pi times 12 squared, and we plug that into our calculator using 3.14 for pi. 12 squared times 3.14, and we get 452.16. And that's meters squared. All right, now let's do circumference. So the circumference is 2 pi r, so 2 times pi times 12. And again, we use 3.14 for pi. And we get 75.36. And that's meters. And that's it. All right, so now let's go and do number 2. Number 2 gives us the diameter this time. It gives us that the diameter is 18. Well, we don't need diameter for the area. We need radius. So remember, the radius is equal to half the diameter. So let's take that diameter and let's find the radius. So if our diameter is 18, our radius is half of 18, so that's 9. All right? And sometimes you'll have to do that. So for our area is pi times r squared, and r is 9, so pi times 9 squared, and we use 3.14 for pi. And we get 254.34 square inches. All right, now for circumference, we can either use 2 pi r or pi d. So I'm going to use 2 pi r. 2 times pi times r is 9. And again, use 3.14. And you get 56.52. All right, moving on to number 3. For number 3, you are given that your radius is 2.8. And that gives us exactly what we need. So area is pi times r squared, 2.8 squared, and 3.14 for pi. And that gives us 24.62 square feet. And then for circumference, 2 pi r, 2 times pi times 2.8, 2 times 3.14 times 2.8, and that gives you 17.58. Notice I'm going to 2 decimal places with all of these. I want you to do the same. All right, and the last one gives us a diameter of 35. You see how that goes all the way across the circle there. So our diameter is 35, and we need our radius for our area, so we have to do 35 divided by 2, and we get 17.5. All right, so now we can find our area. Area is pi times r squared, so 17.5 squared. And so we get 17.5 squared times pi times 3.14 for pi, and we get 961.63 kilometers squared. And then for circumference, we do 2 pi r, so 2 times pi times 17.5. And we use 3.14 for pi. And we get 109.9. All right, so that's how you look at a picture of a circle and find area and circumference. Now let's go on to the word problems, your favorite. I know how much you love these. All right. In these word problems, they give us information and ask us to find certain pieces of the circle. So it says, find the diameter of a circle with a circumference of 65.97. So they, excuse me. So they told us the circumference. So the circumference is 65.97. And we know that that circumference formula is pi times the diameter. So we have 65.97 equals pi times d. And d is what we're looking for. So if we can just get rid of this pi, we'll be in good shape. So to get rid of pi, we're going to divide by pi on both sides. So we're going to divide by 3.14. So 65.97 divided by 3.14 gives us 21 for the diameter. And it's like 21.01. And that's it. All right, now let's take a look at number 10. Find the radius of a circle with a circumference of 21.99 feet. Now, we know that the circumference is 21.99, and we also know that the circumference formula is 2 pi r. Now, notice this time I used the formula with the r in it. And that's because the part that I'm looking for is the r part. So I don't want to use the diameter formula here because I'm not looking for diameter. I'm looking for the radius. So I have that 21.99 equals 2 pi r, and I'm trying to get that r by itself. So I'm going to get rid of the 2 pi. So I'm going to divide by 2 pi on both sides. And 21.99 divided by 2 times 3.14 is 3.50. So r equals